it says to divide the expression using the quotient rule. I've got two different problems here. And I'm going to do this one first, but in the process of doing this, I'll explain what the quotient rule is. We have x to the fifth divided by x squared. So we can write this out. Instead of writing x to the fifth, we can just write this out as x multiplied times itself 5 times in the numerator, and in the denominator be x times x. So now I can reduce this by canceling any x's on top with x's on the bottom. So that one goes away, and that one goes away. And what we're left with is x times x in the numerator, which is x to the third. And then in the denominator, there's just 1. So this is just x to the third power. And that method works just great when the exponents are small, but I wouldn't want to have to write out 34 x's in the numerator and 20 of them in the denominator for this problem. And we don't have to. The quotient rule will allow us to do that without having to write it all out. Now, the quotient rule is how we can get from here to here. Notice that all we had to really do was take that numerator exponent minus that denominator exponent, 5 minus 2, to get the 3. So the quotient rule, if we generalize this, would say that if we have x to the m on top and x to the n on the bottom, then the result is x. Notice it's not a fraction, it's just x, the same base that these two guys have, and then the exponent is m minus n. So we're going to do that with this problem. We're going to say this is both of the bases are the same, so it's going to be x to the 34 minus 20. So that means it's going to be x to the 14th power. So we got x to the 14th for this one, and this one we had x to the third power. And that's how you divide these expressions using the quotient rule.